Okay, it's past Berkeley time, so I'm just gonna go ahead and get started. So welcome to the React 3 lecture. This is gonna be the last lecture for React, and we're gonna go over a high-level overview of a bunch of advanced topics. So Axios, project structure, and some other like ecosystem stuff. But before we do that, let's quickly recap what we know so far about React, since it's been a while since we've covered React. To reiterate, React is a JavaScript library for building user interfaces. And in the last lecture, I went over React routing, I went over useEffect, and I went over styling libraries. So yeah, we went through how to handle all of those different things in our React projects. And those are just like things that take your React project to the next level. So like routing, you can implement multiple different like pages in your application, and then styling makes it a lot easier to like handle making your website look really nice and making the ability to create really nice websites really fast. Yeah. So today we're going to go over backend integration, React project structure, server-side rendering, and then React ecosystem. So these are a lot of advanced topics. So I'm only going to do like a high-level overview of it, and not really go too in depth, except for Axios, because that's going to be pretty important for the final project. And if you've already done homework 5, then you kind of have experience with Axios, but I'll go over that again. Okay. So to start with backend integration. So the library that we use to integrate our backend with our front end is Axios. So if you remember from the JavaScript lectures, it's the way you connect to an API, you would use a method called fetch. And Axios is similar to fetch, but much better. And it actually works on more browsers. Surprisingly, like fetch doesn't really work on Internet Explorer. Not really sure why, which is kind of because it's a JavaScript built-in function, but it's kind of interesting that it doesn't work there. Yeah, so Axios is like fetch, but improved. So it's a promise-based HTTP client. So it allows us to make HTTP requests to a server. So if you remember from your backend lectures, there are a few different types of HTTP requests we can call. So there's like get, post, delete, update, and a whole bunch of other ones. So these HTTP requests are like API calls. So you make the call to a server, and the server will return some data from the backend. So this is how Axios kind of allows us to seamlessly integrate the backend and front end through these HTTP requests. Are there any questions on what Axios does before I go into a demo? So I'm showing chat. Where's my chat? Ah, here it is. Does it call fetch internally? So Axios has a bunch of methods like get, post, delete, update, like all the HTTP request methods. I guess for fetch would be equivalent to fetch. I don't exactly know how Axios works internally, but I would assume it kind of acts as almost a wrapper to the fetch method. But I think Axios might be an open source library, so if you wanted to look it up, like you could probably find the GitHub for it. It isn't really important how Axios works. So like if you've already done homework 5, then you might be familiar with this type of syntax. So in order to use Axios, you have to install it into your React app and then import it from there. So, and then to like make a GET request from an API, you would do this. You would do axios.get and then the API URL, and then that would return a promise, which you would then have to resolve with like by calling the .then function. And if like it returns an error, then you have to catch the error. So this is like a simple example about how an Axios call looks like. It should be familiar to you though. And most likely on your final projects, you will be using Axios. Okay, but I'm going to go through a demo of a like more in-depth example so you can kind of see how it works. Okay, so can everyone see my screen? I'm assuming yes. Oh, this is another. Okay. I don't know what I just did. Okay, this is very weird. Okay, this is the one I wanted to go over. So we have this example. So I'm just going to show this example on Code Sandbox, which allows you to like write out JavaScript code and it'll like it automatically load into this browser instead of like having everyone go through a demo like on VS Code or something. So we have this example and I'm going to show on the browser how it works by refreshing the page. So if I click this Get Next Name button, it'll populate the page with another name and picture. And if I keep going, it'll just keep populating the page and so on and so forth. So let's go through from the start. I have 2 state variables. I don't know why I did that. I have 2 state variables, user info and page number. User info is a list and page number is a number. So user info, like if you can infer from like how the website is working, would correspond to these list of names and images that are being displayed. And then here I have a function get random user, and this function is what is actually like handling fetching the user info from the API and returning it. And then there's another function, fetch new user, which we'll call get random user. And then finally, there's a useEffect hook, which essentially what this useEffect block does is it calls fetch new user when the page loads initially, because I passed an empty array into the dependencies. I do have another demo for useEffect. So would people want me to go over that really quickly? Because this lecture has some extra time, so I could go over that. Could I get like maybe a thumbs up if you want me to go over useEffect? If not, we can just continue with this. Okay, I see a few thumbs up, so I'm gonna go over useEffect. Okay, so I have another demo here, and this is kind of this is kind of showing just how useEffect works. Nothing else is really happening here besides that. So essentially on this page, there is a input box and I can type in a number of characters, and then when I reach 5, it should change this box here to say valid input. So useEffect is like another React state management hook. So like useState is used to track our like the state of our variables that we initialize in our components. useEffect is like a way to how do I put it? It's a way to manage the rendering of those variables. So let's say is there a way to take out this? Actually, no. I had a better example in the other lecture, but essentially React, the way the React lifecycle works is everything on the page is loaded at once. So if something like a variable changes and you want that to reflect on your page, you need to somehow tell React to re-render your page, because even if like the variable itself will change, like the page won't re-render because React loads everything out once, if that makes sense. So useEffect is a way to trigger a re-render when one of our variables changes. So there are three. So with useEffect, it takes in two arguments. The first one is a function that is called on like when you want to render something. And then the second input is a list, and it's a list of dependencies. And these are the dependencies that would trigger a re-render. So like the re-render is dependent on your dependencies array, if that makes sense. So here we have input in the dependencies array because this function here relies on like the value input changing, being updated. So you can see down here in this paragraph, you have a Boolean variable is valid that will change the background color and the text of this like box. And this function block is what is updating that Boolean variable. So like say I take this out and have an empty dependencies array, even when I type something in, oh, what the happened there? That's so interesting. I don't know why I did that. When I type something out, this is obviously like way longer than 5 characters, but the box isn't changing because this function block is not running, even though the length of our input has changed. Even though this variable itself input has changed when I type in it. So I'd have to pass in input here, which would trigger when this variable is updated, it would trigger a call to this function. So type in something here, we'll see that it goes back to the default behavior. So there's 3 cases. The first is if you pass in an empty array into your dependencies. In this case, useEffect is only called when the page first renders, when the page first loads, and it won't update after that. And then if you pass in a variable, then this function will run when that variable is updated. And finally, if you pass in nothing into your dependencies, then useEffect will always be called, like when anything in the file changes. So if input changed, if isValid changed, like useEffect would be called. Are there any questions about useEffect? Okay, if there are no questions, I'll go back here. So you can see that in this code, where we're making our Axios call, this useEffect hook is only going to be called when the page first loads because we passed in an empty array. So let me refresh the page and you'll see that we already have like one name and image on the screen because when the page initially loads, it will call fetch new user, which fetches from the API. Okay. Even in, I was going to say, even in homework 5, we have like our posts, our like posts from the backend that we fetch initially. And we use a use effect hook to fetch those. So that's why like our page is populated with posts, even though we haven't even created a post, because we're getting like the initial posts that are already stored in the backend. So that's the use case for use effect. Okay. So to get into this get random user function, it takes in a number, and that number is going to be passed into the API directly. So we use these template strings, which so this entire thing is called a template string, and backticks indicate that it's a template string. And essentially what a template string is, if you remember from the JavaScript lectures, it's a way to inject like a JavaScript variable like directly into your string. So this number directly corresponds to the number that's passed into the function. And then from there, we get the data from the API like fetch response, and then return that. And then from that data, we use that data to update the user info array, and then increment the page number by 1. Oh, I see a question. Whenever a state changes, re-render, does it rerun everything in the component from top to bottom, declare variables, define random user again? Yes, it does. Yeah, so when the page re-renders, it's basically just running your like app, like your component from start to finish, which is why you want to be careful about like using use effect, because it really slows down your app if you're constantly re-rendering the page. So it's not really good practice to pass in just like nothing into use effect, because that would trigger a lot of reloads and that would be really slow for the user. Okay. So what is this here? I see. So the dot then function takes in another function, and that's what you use to get the response from the call to Axios.get. So let me just copy and paste the API. I could console.log it here and show it there, but another way to view an API response is to just copy and paste it, and then you can see the JSON object that's returned from there. And then if I just do a JSON formatter on this, okay, you can see that my JSON data looks like this. It has results, which is like an array. And then within that, we have like another JSON object, which has the name, the first name, the last name, and so on and so forth. Whatever information you need about this random person. And then it also has a URL for the image. So if I go back to my code sandbox, you can see that here I'm doing info.name.first and info.name.last. So user info is a list that we got from the call to the API. So this one returns an array of JSON objects, and then we append it to our user info array using the JavaScript spread operator. So this is our old user info, and this is the results array that we get from the API response that we also use the JavaScript spread operator for. So then the new person is like appended to the end of our list with this syntax. And then from there, we call the map function to like process our user info array. So you can see that I'm using the dot notation to get the name and then the first name. And then I'm using the dot notation again to get the last name, like dot name, dot last. And then to get the image, you can see from the source URL, I'm doing, where is it? Dot picture, and then is it dot thumbnail? Yeah, dot thumbnail, because then we want the smallest one. So that's kind of how you parse a JSON object. And in general, the data that we get from Axios is in JSON object form. So in fetch, we would have to do response.json directly in order to convert our response to a JSON object. But here, the data is already formatted for you in the JSON. And I could also do this. I could say response and then just do response.data like that, and it would still work. Oh, refreshed. But I'm using this like curly brace notation to essentially destructure our response object and get out the data property, which is like where all of the API responses in. Okay. Is there any questions on this syntax, like how this specific example is working? For the dot, then we can leave out the parameter, but why does it still work? Which dot then are you talking about? The one here? Or the one here? Oh, the one on line 13? Oh, what do you mean leave out the parameter? So the dot then function, dot then takes in a function which has one argument, which is like our response object. And from that, we extract out the data from the response object. Does that make sense? Like we're not really leaving out the parameter. I mean, the server returns the data. If we don't want the data, we can define a function taking no parameter. I don't see what the point of that is, but technically you can, I guess. I don't know why you would do that, but you can. Okay. Are there any other questions on this syntax? Okay. There's no other questions. I think I'll move on from Axios, but hopefully this helps you understand like how we would use this specific library to connect to our backend. And hopefully it helps with homework 5 if you haven't already gotten through that one. I'm going to go back to the slides and move on to talking about, I'm just going to skip that because I basically already got over this. So I'm going to move on to talking about the anatomy of a React app. So the reason I wanted to go over this is because we use create React app, but there's a lot of different things happening within that one like project. And right now we've only really dealt with the source folder, which is kind of where all our code and components are, but there's a lot of other things happening within the React app that I think is important to know. So if this isn't familiar to you, essentially this is like the structure of a React app created with Create React App. So we have the source folder, which is where all of our logic goes. The public folder, which I might have gone over in the first React lecture. This is essentially a folder of like assets and also our index.html file. So the public folder is what contains all the stuff that is displayed to the public, and it's kind of connected to our source folder through index.js. I went over this in React 1, but I'm briefly going over what it is now. So obviously there's a README, which is like how to run, I don't know, it's like basically instructions on how to start a React app, not really that important. There's node modules, which is like a folder of essentially like all of the dependencies needed for Create React app. Specifically, it really depends on whether you use Yarn or NPM, but it's a huge folder. It contains so many dependencies, and these are like all the dependencies that we would need, like all the libraries and frameworks that are needed to make this like React app work. So I think NPM specifically, which is Node Package Manager, uses the most dependencies. And obviously, if we looked into the folder, you'd see there's like thousands in there. And there's a reason why we use package managers in the first place, because it would be a lot of overhead to manually install all of these instead of just having a package manager do it for us. And then package.json, which is pretty important. So it's a file which lists like kind of the metadata and also other like development dependencies that we would need. So how it's different. So it's a little bit different from node modules, because node modules is like all the like packages and stuff that we would need to make this app like run. Package.json contains like Axios or Jest if we wanted to do testing, or any other like packages we would need for development. Like Chukra UI also goes into package.json, icon folders go into package.json. So it's kind of like the dependencies that we need specifically for the app that we're creating, not just for Create React app in general. And then package lock is just like a locked version of package.json. So like it ensures that we have all the correct dependencies and things don't break when we try and download things into our package. And then finally, we have a build folder, and this build folder is essentially like when you run npm run build, this is where the output of that command goes. It's like a compressed version of our project that you can run to the public. Okay. Are there any questions on that? Why is my chat not so up? This is very annoying. Is package lock a dependency of a dependency? Can you explain what you mean by that? Mm-hmm. My NPM aims. Um, that's not really how package lock works. Essentially, like if your package A has like a version update or something, then package lock will enforce that version update so that nothing breaks when like developers try and push updates to specific like libraries. Okay. This is not close. Fine. Okay. So this is more like some general tips for designing React applications. This would probably be helpful for when you make your final projects, but it's important to like plan out your project before you actually start. Don't make too many components or go into things blind because you end up making a lot of unnecessary changes. So like know what components you want, what they're going to look like, what the state for each component should be before you even start coding. And it should help with structuring your project. Yeah, these are just general tips to think about when you do your final project because that is going to be all from scratch. So, okay. So moving on to server-side rendering, I'm only going to touch on this very briefly. Essentially everything, I think I explained this earlier in the last lecture, but React is uses client-side rendering. So essentially everything is loaded onto a pre-rendered DOM within our own browser, and then we when anything changes, it'll be reloaded from that client. But sometimes client-side rendering can be pretty slow for the user. So that's why we also use server-side rendering, because performance is very important when running web applications. So essentially how server-side rendering works is it loads all the HTML elements onto the page before the JavaScript itself has started loading. So the user can see the page at least, even before the JavaScript has finished running. So even before they can do something, at least a user can see the page and like, I don't know, plan out how they want to what they want to do on the page. So it's kind of like a small efficiency improvement that really affects like how users interact with the page. So nothing really changes with server-side rendering except for like the order in which things load. So HTML comes first before our JavaScript is finished running. And Next.js is a framework that uses server-side rendering. I won't go too much into Next.js because it's not really important, but just so that you know, I think also Next.js is just a useful framework to know about because in the future you might see it pop up. Yeah, are there any questions on server-side rendering? It was very brief. I'm not really going to go into it too in depth because it's a little bit out of the scope for the class. It's just important to know conceptually. Okay, well, if there are no questions, I'm going to move on to React ecosystem. And this will be like the last thing I cover for today. So the first thing I want to go over is Redux. So Redux essentially is a framework that helps you manage global state. So we already know like how to manage state within our React application. It's through using our state hooks and also props. So that's how you pass state variables in between different components. Redux is just kind of an improvement on this. And I'm going to quickly show a diagram for why we want to use Redux. So let me close this. So right now we've only created applications that are small enough that we don't really need to consider global state because there's not that much going on component wise. So like say we have this application structure. So we have our app component, and then app has 3 children: login, inbox, and search. And then inbox contains another component, which is just like one specific email. So this is like a mail application app. And this red star is gonna indicate state. So we already know like if I wanted to share state between inbox and one email, you can just pass it through props directly, right? So pretty simple, like the parent has the state variable and that's passed directly through a prop to the child component. And what if I wanted to pass it from inbox to search? Or what if I wanted inbox to search and inbox to one email? So it's a lot harder to pass data between sibling components, but it is possible. Like if you wanted app to control the state, then it can pass it to inbox. It can also pass it to search, and inbox can pass it directly to one email. Not really complicated so far yet, but think about if you had like multiple sibling components or multiple children in between. So like I had one more component in between inbox and one email, or like 20 more components in between them. So like once your app gets incredibly big, it doesn't make sense to have your data shared in this way because it ends up being really inefficient, and you have all these weird calls and components that are storing references to state that don't really need to manage the state in the first place. Like another possible use case could be like I have, I don't know, state here and I wanted to pass from, and this one so I have this component which is like a child of search, and then I wanted to pass from here to here when they're not even directly related at all. Like the only way that this component inbox is related to this child component here is like through app. So for apps which have like complicated use cases for state, it makes more sense to use global state management, which is what Redux handles. So instead of having like all these stars, each component keeping track of its own state is now stored in Redux here. And this is, Redux calls it the Redux store. And essentially like the state is managed within this one entity, which I'm representing with the circle. And like if a component wanted to get something from the store, all it had to do was like directly connect to the store instead of having to worry about props and like functions that like allow you to pass data back up from child to parent. So it makes things a lot more clean. So like if this component wanted to directly like change a state variable, all it had to do is like, I think, dispatch to the store and then update the state like globally. So for across all components. Yeah. The one thing about Redux though is that it's a lot of it solves a big problem, which is global state management, but there's a lot of overhead and a lot of there's a kind of a steep learning curve in order to understanding Redux. But so like for personal projects, it's not really that necessary to use Redux, because there's like very minimal need for like global state management, and it's a lot of like new syntax and concepts to learn. But a lot of like company projects will use Redux because the project itself is just so huge that it needs global state instead of having each component store its state locally. So like if I do React Redux, let's see if I can find the documentation. So there's like new functions, use selector, use dispatch, which you import from the React Redux library. And there's just a lot of learning to do with this. Like React Redux provides its own like new hooks, like use selector, use dispatch, use store. So like I'm just showing this to explain like that React Redux is useful, but it's complicated to learn. But the reason why we're teaching this right now is in case you see it in the future, like at a company that you work at, and that you're not like caught off guard. Like, what is this React Redux? Like, why are we not using props anymore? It's because like maybe they're using global state management instead. Yeah. But are there any questions about why we would want to use Redux instead of like the other way that we know how to manage state? We have use context for passing data to children that are very low in a tree. So why do we need Redux here? So that's true. But again, what I was indicating, like I was trying to show with this example, like, sure, it's possible to pass from like this all the way down in the tree. But what if you want to, there's no way to get from here to like a sibling component's child, or like even to a sibling component. So like, it doesn't make sense for app to control all of the state, because app doesn't need to keep track of the state for every single variable. It ends up making your project really complicated and the logic itself kind of ugly. So why have app control all your state just for these two components to interact instead of just having it managed globally? Okay, are there any other questions? Okay, so then I'm going to move on from Redux. That was just a brief overview. The next thing I wanted to go over quickly was TypeScript, and I think that's our last topic for today. So as you know, types in JavaScript are dynamically assigned, not static, like a language like Java, for example. So like you have variables, like you have const, lets, and vars, but you can do like const x equals 5 or const x equals the string hello world. Like the type of the variable is assigned after you make a value for it. So essentially that makes like running JavaScript a lot slower because the types aren't statically assigned. And so when you compile JavaScript, you have to first like infer the types of your variables before running it, and it just makes things a lot slower. And TypeScript also helps prevent like runtime errors in case you have some sort of type mismatch between your variables, like something is expecting a number, but you made it a string, like that. So that's what we use TypeScript for. It basically like enforces types onto your variables to prevent these like runtime errors and also to improve like the compile time. So an example of this is in our homework 5, actually, just to go back to it. So you know how we have to make a new post with like an ID, title, and body. And there were instances where if you could type anything that you wanted into those input boxes and post it to our database, but like what happens if your ID is not a number? Technically, your post request will go through, but then you can't fetch that specific post because the database is expecting a number. So this is an example of a use case where we want to use TypeScript because we would want to enforce the ID being a number, or the title being a string, or the body being a string, so that what you're putting into the database is exactly what it's expecting. So I'm just going to quickly go through the differences between TypeScript and JavaScript. So TypeScript is on the left. You can see that it's .ts instead of .js, and then JavaScript is on the right. So here, like we define a function, exclaim, and even within the function argument, it takes in a str, which we can infer from the name is a string, but you use these colons to indicate the type of the variable. So str is explicitly typed as a string in TypeScript, whereas in JavaScript, str is just like implicitly in like a string because of how we are like appending to it. Yeah, so that's how you indicate like the type of variable. You use this colon notation. There was a bit like a bigger example, but I think this is enough to show that like the key differences between TypeScript and JavaScript. Are there any questions about TypeScript? Okay, well, if there are no other questions, then that's it for this lecture. We ended 30 minutes early because I was only doing some brief overviews of the topics. But yeah, feel free to stay behind if you have any more questions, but that is it for today's lecture.